Hey everyone, in this video we will understand one of the searching algorithm. Name of that algorithm is linear search. So basically we will understand what is linear search and how basically it works, okay, with the help of example and the pseudocode and with the code also, okay. So I will basically tell you the iterative method, okay, to implement this linear search. And in the next video we will see how we can implement linear search using the recursive code or in the recursive approach, okay. At the end of the video, I will also tell you the time and space complexity of the linear search using a iterative method. Okay, so let's start our video. So what is linear search? The linear search is basically a searching algorithm, and this algorithm or method is used to find a number, or you can say an element or a key from a given collection of numbers. Okay, and the numbers that are given as a collection, that collection can be in unsorted manner or it can be in sorted manner also. Okay. And finally, this linear search algo tells whether that particular element or the key is present in that collection of number or not. So let's take the example. So let's say we have 6 numbers, okay, 7, 4, 8, 1, 10, minus 13, right? And I have to search a number and the number is 10. So the number that I want to search is represented by key, okay? So here you can see 10 is actually present in this collection, right? So my answer will be 10 is present by the linear search. Okay. Now let's say we have 11 numbers. Okay, these are the 11 numbers, and here you can see some of the numbers are repeated. Okay, they are occurring more than one time. Like here you can say minus 13 has occurred 3 times. Okay, linear search algo will work perfectly fine on this type of arrays, or you can say collection of numbers also. So I want to search minus 13. So here you can see minus 13 is present, right? Minus 13 is present here, here also, here also. So basically my algo will say yes, minus 13 is present. But let's say you want to find a number 50, okay, and in this collection of number 50 is not present. So my output will be by linear search will be 50 is not present. So I hope you have understood that what is the input for your linear search algo and what will be the output given by your linear search. Okay, so now let's see how this linear search algo will actually work and how it will be able to find a number inside a collection. Okay, so here we are given collection of numbers. I will call this collection as the array. So we are given numbers in the array as 7, 4, 8, 10, 1, minus 13, and the index of the number or the position of this number starts from the 0. So 7 is sitting at the 0 index, 4 is sitting at the 1 index, and so on. Okay, now I want to search or find a element that is 10. Okay, this is the key element that I want to search in this array. I want to know whether 10 is present in this array or not. Okay, and you can see this is an unsorted array. Okay, if it were to be a sorted array, then also linear search algo can work perfectly fine. Okay, so now let's see how linear search algo will work. So basically I will first check 10 with the 0th element. Okay, I will see okay, if key element that is 10 is equal to 7 or not. So 10 is not equal to 7, right? So linear search algo will say, okay, now check the next element. Okay, so I will check the next element. So I will check my key element with the next element, that is 4. Okay, now 10 is not equal to 4 again. Okay, that means I have not found my element till this point. Okay, now next element will be checked. Okay, so next element is basically 8, which is sitting at the position number 2. So 10, that is the key element, is again not equal to 8. Okay, so basically I am comparing my key element, okay, with each of the element, right? So 10 is not equal to 8. So I will say, okay, maybe my key element can be in the rest of the array, right? So basically I will now move to the index number 3. Okay, and I will check, okay, my key element, that is 10, is equal to this 10 or not. Basically, yes, my key element 10 is basically equal to this element. That means I have found my element. Okay, that is my 10, that is key, is present in the array. Okay, so my output will be yes, 10 is present. So now my linear search algo will stop here at this point. Okay, now let's say if I want to search minus 13 in this array, then what will happen? Basically again I will actually search in a sequential manner. Okay, in the same way I will check my minus 13 with the 7. Okay, it is not equal, so I will check with the next element, minus 13 with the 4. Okay, again it is not equal, so I will check with minus 13 with the 8. Okay, it is not equal, then minus 13 with 10, again it is not equal, minus 13 with 1, not equal, minus 13, I will check with this element, so it is equal. Okay, my key element is equal to this fifth index element, that is minus 13. Okay, so now again I will say yes, minus 13 is present. Okay, so here I have searched the element which was actually present in this array, right? Now it can happen that my element or the key element is not present in the array. Let's say I want to search 100 in this array. Okay, now you can see 100 is not present in this whole array, right? So for this my answer should be not present. Okay, or you can say 100 is not present in this array, right? So basically again my linear search algo will work linearly. Okay, in the sequential manner it will check with each and every element, okay, that my key is equal to any of the element or not. Okay, so minus 100 will be checked with this 7. Okay, it is not equal. Okay, 100 will be equal to 4, not equal. 100 is equal to 8, no. Then I will check if my 100 is equal to 10, no. My 100 is equal to this one, no. My 100 is equal to the last element, that is minus 13, no. And now after that I cannot check with any of the element because there is no other element. Okay, so after we are at the end of the array and my element is also not equal to the end of the array, that means my key element is not present in the array, and then my output will be 100 is not present in the array. Okay, so basically my answers can be two. Okay, either element can be present or either element cannot be present. So now let's understand the iterative solution to implement this linear search. Okay, so here is our algorithm. Basically we will understand that how we can write the algorithm. Okay, so basically I will write the pseudocode. Okay, not the plain English word. Okay, so linear search is the function. Okay, so linear search function will actually take some of the input from the user, that is the array, then the size of the array, then the key. Okay, so in this question we have, let's say, this collection denoted by array A. Okay, so this is an array and the size of the array is denoted by n. So we have total 6 elements, 1 2 3 4 5 and 6. So I have denoted n equal to 6. And my key element, okay, I want to search. So key can be anything that I want to search. Okay, I can search, let's say, 8 or 10 or 1 or minus 13, or key can be like any element which is not present. Okay, so this 3 inputs, okay, they will be given by the user. Okay, now this linear search algo will actually print whether my key is present in this array or not present. Okay, now I have used the word algorithm because I am simply writing the algorithm, or you can say a pseudocode. Okay, so it doesn't matter whether I should write algorithm or any other keyword. Okay, you can use the function word also. Okay, so it depends like which book you are referring. Okay, so it doesn't matter. Let's understand this pseudocode. Okay, as you have understood in the previous slide that linear search was actually checking my key element with each of the array element one by one. Okay, starting from 0 to last element, right? So basically I can use any loop which can do this repeated task. Okay, so I have taken a for loop. You can take any loop. So I have taken for I equal to 0 till I less than n. Okay, so basically I can just check from 0 to 5. Okay, when I value will become 6, then I will actually terminate, okay, my work. Okay, I will terminate my work, right? So I will keep on updating this I starting from 0, then I will update it to 1, then I will update it to 2 and so on. Okay, so I have written this thing. Now my linear search can tell whether my key is present, okay, when I am checking with each of the element, or my linear search algo can say key is not present. So there can be two output. Now how they will be printed? So basically I am checking my key element with this 0th element. So this 0 element can be called as A0, 7 can be called as A0, and 4 can be called as A of 1, right? I hope you know that what is array and how this works. Okay, same 8 can be written as A of 2. So basically what I will do, linear search algo is saying check if key element is equal with A of I or not. Initially I have I equal to 0. Now I will check, okay, let's say key is 10 that you want to search. So I will check whether my 10 is equal to A of 0, that is 7. I will say no. Okay, 10, okay, that is key element, it is not equal to 7. Okay, so I will say okay, just go to I plus plus. So now I will be your 1. Okay, so I will come here. Okay, now I will check whether 1 is less than my array size. Yes, okay, 1 is less than 6. Okay, now I will say my key element is equal to A of 1, that is 4. Okay, So 10 is equal 4? No. So I will say, okay, I have not found the element till now. So now next index will be 2. Okay, so I will be 2. Now I will check my 10 with this 8, that is a of 2. So 10 is equal 8. Again, it is false. So I will not come inside. Then I will update this I and I will come here. Then I will check again key element, that is 10, okay, with my a of 3, and a of 3 is 10. So my 10 is equal this a of 3, okay. So this condition will be true, right? And I will say yes, my key is present, or you can say your element 10 is present inside your array, okay. Now after this, okay, you do not have to again search your element, okay. That means you do not have to go till the end of this, you can say, array, okay. You have found your element, that's all, okay. You can stop your searching, right? So basically I will apply a break statement, okay. So break will say, okay, now you can terminate this loop, you can come out of this loop, right? Okay, so yes, my linear search algo has stopped, okay. Now if I write this code, okay, so this code will actually print one extra line also. Let's say for 10, my answer will come as key is present, and another answer will be key is not present. Both will come. Why? Because after break, this control will come here, and here we have written key is not present, right? So basically what will happen? My both answer will come, and user will be confused whether your key is present or not present. So what should I do? Basically, I do not have to print this message when key is present, okay. Either I can print this message or I should print this message. Only one message should be printed. So basically this message should only be printed when key is not present, right? So basically I should use any if condition, okay. I should use any condition here, so that this statement will be printed only when your key element is not found in the array. Let's say you have to search a element, okay. Let's say you have a 100 element, okay. This you have to find in the array. Now 100 is not present in the array, so your output should be key is not present. So how you will do? So linear search will say, okay, 100 will be checked with 7, okay, then 4, then 8. So okay, so inside this loop, okay, I will keep on checking 100 with the, you can say, a of 0, then 100 with the a of 1, okay, then 100 with the a of 2, that is 8, okay, then 100 with the 10, okay. So it will not be you can say equal with any of the element, okay. Then 100 with the a of 4, okay, it is not present, okay. Then lastly I will be, you can say, 5, okay. Now 100 is equal to a of 5, that is minus 13, no. So again I will go and I will say I plus plus, that is 6. I has come out of this array index, okay. I has come to 6. I will check whether 6 is less than, and the array size is, you can see, 6. So 6 is less than 6? No. So this is false. Now I will come out of this loop. Now I have to print key is not present, right? So when key is not present, my this answer will present. So when key is not present, my this answer will be printed. But the problem was when key is present, then both these answer will come, right? So what should I write here so that, okay, when the element is not present, only this message should come. When key is present, only this message should come, and this should not be printed. So basically you can see a property, or you can say a situation when key is not present. When key is present, okay, then your I will not exceed this index number 5, okay, for this example, right? Let's say you want to search minus 13. Then what will happen? I will come to each element and compare, okay. When I will come here, basically, then I will say, okay, my minus 13 is equal to this a of 5 minus 13. Yes, and I will say yes, key is present, and I will break. Actually I will not update I to 6 now, okay. I will break. So when I will come out, what will be the value of the I will be at 5. So whenever your key will be found in the array, maximum your I can reach to the last value of the array, or last you can say array index, that is n minus 1, okay. For size n, okay, this is the, you can say, n minus 1 index. So my I can be n minus 1, or I can be like lesser than n minus 1 in case my element, that is key element, is present in the array. But when my key will not be present in the array, then my I will be greater than your n minus 1, or you can say I will be equal n, right? For this example, n is 6. So basically when 100 was getting searched in this array, I reached to 6. that is it become equal n. Okay, so I will use this property. I will simply say if I is equal n, that means key is not present. I can only reach to n when key is not present. Simple. So this condition will only be true for this case, when your element will not be found in the array. So let's run this code. So this is our code. So here, this is the linear search function. Okay, and this is printing key is present and key is not present. Okay, and the return type is void. Here is the main function. So it is asking for the array size, array elements. Okay, and after that it is asking the key that we want to search inside the your array. Then we have called the linear search function by passing the three arguments: array size, the array, and the key. Okay, so let's run this program and see what is the output. So it is asking for the array size. Okay, let me enter 5 numbers. So let me enter 5 numbers. Okay, so I have entered the 5 numbers. Okay, now let's search any element. Let's search 3. Okay, so here 3 is present. Okay, let's run on the other input also. Okay, let's see, we have 7 elements. Okay, and let's enter 7 elements. So here I have entered 7 elements: 5, 6, 22, 40, 91, and then 10. Okay, now let's search 100. Okay, as 100 is not present in this array, so our answer is 100 is not present. Okay, so I hope you have understood that how this program is working. Okay, and now you can check for the corner cases also by yourself. Like if size of the array, that is n, is equal 0, then you can just simply print that your array is empty. Okay, let's move forward. Now before going forward, let's say you have this 10 here also. Okay, that is at the 6th position. Okay, that means you have total 7 elements. Now how your linear search algo will work? So linear search algo is just saying, okay, just check whether your element is present in the array or not. Okay, this is the algorithm. Now in our code, linear search algo will come at this point and it will say, yes, your key element, let's say it is 10 is present. Okay, at the 3rd index. So your algo will break and it will say, yes, key is present, right? So even in the case of duplicate numbers, then also it will work the same way. Okay, now it depends on the application to application where you are implementing this linear search. Your implementation can somewhat vary. Okay, if you want to find the second occurrence of this element 10, then you have to stop at 6th position, right, using the linear search algo. Okay, so you can just modify a little bit linear search algo. Okay, now let's say if your friends say that we want to modify this linear search algo in the way that linear search algo, okay, here it should not present whether your key is present or not. These messages should not be present here. These messages should be, you can say, printed in the caller method. That is, let's say in the main function, these messages should be printed. From here, you should return true or false. If key is equal AI, you should return true. Okay, from this function. And if your element is not present, then you should return false. Okay, then how your code will look like? So your code will look like this. If key is equal AI, you can simply say return true. So return will say, okay, break the control. Okay, so your return will say, okay, I am returning. Okay, returning where? Returning to the caller function. Okay, so in our code, as we have seen, this code was called by the main function. So control will go to the main function, right? Similarly, let's say if you are finding element 100, okay, then what will happen? You will come out of the for loop because this condition will never be true, right? So you will come here. You have come here. Why? According to this code, you can come here only when you get this condition false, and you can get this condition false only when your I will be greater than n, and I can be greater than n only when your key element, okay, key element is not present in the array during linear searching, right? So you have come here, it means you can simply return false. Okay, you do not have to check if I is equal n or not. Okay, you can simply say return false. That means your key element is not present. False is saying not present, and this is saying present, right? So in the caller function, we can now check if the main function has got true, that means it will print present. If main function has got false as the you can say return value, then it will say not present. Okay, so let's see this code also. So here I have written this code. So here my code is returning true or false. So that's why I have taken a data type pool. Okay, that is present in the C++ also. Okay, and if you go down, as this linear search method is returning true or false, So basically I have to print the message here like he is present or not present. So basically your linear search algo will be called and true or false can come. So basically if true will come, then if, then here this call will be replaced by true. Okay, if true is returned. So if true means yes, key is present, and if linear search return false, then if condition will become false, then I will print key is not present. Okay, basically your client, or you can say your main function, is actually printing the messages. Okay, this function is just returning true or false. Okay, so let's run this program and see. So here I have entered the 6 array elements. Okay, 10, 20, 30, 5, 15, 4, and the element I want to search is 15. So here you can see 15 is present. Okay, 15 is present in the array, so it is correct. Let's check on the other input. So let's say I want to search 100 in this input array. Okay, 3, 5, minus 10, 18, 9, 80. Okay, so 100 is not present. Here you can see we are getting 100 is not present. Okay, let's now find the time and space complexity for this iterative solution of the linear search. So basically, to find the time complexity, we have to see that how many times your comparisons are being done, right? Because comparisons are the main, you can say, key things that you have to check while you are finding the time complexity. Okay, so if you do not know what is time and space complexity, you can check out my video in the design and analysis of algorithm playlist, where I have discussed what is time and space complexity. Okay, so basically in this, actually we are doing the comparison here. Okay, and we are also doing the comparison here, right? So basically if you see, I am running this loop maximum how many times? I am running this loop maximum, you can say, n times. But how many times this condition is being, you can say, checked at the CPU? So it is being checked, you can say, for this array from 0 to 5, that is 6 times. But at the last, when I will be equal to 6, then also this I was checked with your n. Okay, when I was 6, that means 7th time also this condition will be checked. So that means when you have the size of array as 6, then 7 time comparison was being done. Okay, 6 time it was true, 7 time it will be false. Okay, you can say this condition is being checked on the CPU n plus 1 time. Okay, when n is 6, it is 7. Okay, now when we are coming inside, we are doing this comparison also. Okay, so how many times maximum, okay, this comparison can be done? Let's say if we want to find the last element, okay, if we want to find the last element of the array, then how many times this comparison will be checked? So basically I will check for 0th, 1, 2, 3, 4, and then I will check at the 5th index also, right? And here this condition will be true, and then I will return true. So basically 6 times this condition will be checked. Okay, because this condition can only be checked when I will come inside, and only you can say 6 times I am coming inside for this question. Okay, so time complexity will be total number of times this loop is running. Okay, n plus 1 time this loop is running. Okay, you can say into what work I am doing in each of the iteration. I am doing this comparison work. So how much time this comparison work will take? It is actually a unit time consuming task. Okay, because this comparison is like a basic operation. Okay, so it will take simple 1 unit time, or you can say it will take order of 1 time. Okay, so in each of the, you can say, repetition of this loop, I am doing unit amount of work. I can say 1. Okay, you can write 2, 3 also. A constant number will be a constant number. You can write 2, 3, or any other constant number also. Okay, it will not matter. Okay, now it will be n plus 1 only, right? So your time complexity will be like order of n plus 1, right? And this can be written as order of n. Now to find its space complexity, we have to see how much extra space is being taken up by your algorithm. So basically your original input was your array, okay, then size of the array, and then key. Okay, this was the input. Okay, and to print the output, you're just printing the message. Okay, so in between you have not taken any extra array, right? Okay, so basically the space complexity for this code will be constant, that is order of 1, right? And if you talk about the stack space also, so here you can see, let's say this linear search will be called by the main function, right? So let's me write linear search as ls. So linear search was called, okay, with the array. Let's say any value of the n will be given as the input, let's say 6, and then some key element will be given. Okay, now after this code is not calling this linear search again and again, right? This linear search is not calling. Okay, These are the simple operation. Okay, so there will be no further call. Okay, and after this code is over, this will be over and the control will go back to main. Okay, so you can say the number of function call, it will remain as one only. Okay, only one time your linear search will be called. Okay, so only one, you can say, activation record will be placed on the stack. Okay, so your n can be even 1000 also, your array size can be 1000 also, then also linear search will be called one time. Your array size can be, you can say, 10 to the power 6. Okay, 1 million also, then also your stack space will be only one activation record will be placed. Okay, so that means your stack space is not being changed depending on the value of n. So that means stack space is also constant. Okay, so no stack space. Okay, no extra space is being taken here also, like no extra array. That's why your space complexity will remain as O of 1, order of 1. Okay, so I hope you have understood this time and space complexity for this algo also, and how this algo is working. Okay, if you have any question, please write down into the comment box. So do like, share with this video among your friend also, and also subscribe to the channel and press the bell icon for notification of the videos. Now in the next video we will see the recursive solution for this linear search implementation. Okay, so see you in the next video. Till then, goodbye.